Hi there everyone, welcome to the video lecture series of eigenvalues and eigenvectors. In this video lecture, I will be discussing the topic called minimal polynomial and minimal equation. It is slightly advanced topic in this concept, and so from now onwards the rigor will start. So let us see how to find minimal polynomial and minimal equation. The concept is very much similar to that of characteristic equation and characteristic polynomial, but there are certain new and deeper concepts that are introduced. So let us see first of all what is known as annihilation. If fx is a polynomial in indeterminate x and A is a square matrix of order n, okay, that is the thing given, and if you have f of A is equals to 0, then we say that this is 0 means it's a 0 matrix. Then we say that the polynomial f of x annihilates the matrix A. That means f of x completely destroys the matrix A in general language. Okay, so f of A is equals to 0, meaning the moment you substitute the matrix A in the polynomial, okay, x equals to A, you write the entire value of that polynomial boils down to a 0 matrix. That is what is meant by annihilation. Okay, now what is known as a monic polynomial? It's a big chunk of what you call the theory over here, so please bear it with me, I cannot go without this. A polynomial in x in which the coefficient of the highest power of x is 1 is called a monic polynomial. Okay, so for the sense, if you have a polynomial, say 3x square plus 2, okay, then it's not a monic polynomial because the coefficient of the highest power over here is 3. But if you have a polynomial, say x cube plus x square plus 1, then your monic polynomial is x cube plus x square plus 1 because its highest power coefficient is 1. Now, what is a minimal polynomial? It is a polynomial whose it is of the lowest degree and it annihilates the matrix A. Okay, the monic polynomial of the lowest degree that is annihilating the matrix A is called the minimal polynomial. So the first thing is that your polynomial should be a monic polynomial, it should be of the lowest degree, and it should annihilate. So there are three things required for a minimal polynomial of a matrix A, and we denote that minimal polynomial by MA lambda, similar to that of CHA lambda. Okay, also if f of x is the minimal polynomial of A, then f of x is equal to 0 is called the minimal equation of the matrix A, similar to that we had seen in characteristic equation. Okay, now this is the concept of minimal polynomial and minimal equation by definitions and theory. There are certain results related to it. I would like to give it to you prior hand going to the problem solving part. They serve really very handy and it's very useful. So the three results are here. First of all, the minimal polynomial of a matrix is unique. You cannot have two different answers for the same minimal polynomial of the matrix. Okay, and now another thing is that minimal polynomial of a matrix divides the characteristic polynomial of that matrix. Okay, so its degree is always going to be less than or equal to that of characteristic equation. And the last one is every root of the minimal equation of a matrix is also a characteristic root of the matrix. So these three are slightly important to us from the point of view of the theory and the problem solving. So let us see ahead what are the steps to find a minimal polynomial. The first step is that you consider your matrix A and find its characteristic equation in the factor form. The third step is you write down all the possible choices of the polynomials whose degrees are less than or equal to the characteristic polynomial. Okay. The moment you list down all the possible choices, then comes the annihilation part. You have to check the annihilation for every possible polynomial that you have written. Okay, only one polynomial of degree less than that of characteristic polynomial will annihilate the matrix A. That is, only one of them will be the correct answer. If no answer is found, then characteristic polynomial is the minimal polynomial. Okay, so this is one very important step. It would be clear with when we see a problem. Now let us, and after that your answer is there with you. Obtain the minimal polynomial of polynomial ma of lambda. That's it. So these are the 5 steps. Remember these 5 steps, because related to this 5 step another concept is gonna get developed soon, and so we will be using it soon. So let us see how to solve an example. Consider this matrix A, which is a 3 cross 3 matrix. We recently saw what are its eigenvalues and eigenvectors. Okay, we have already seen this because in my previous video lecture I had discussed this matrix. Its eigenvalues are 2, 2 and 5, and its minimal equation is what we are going to find. So these are the two characteristic equation forms. This is the polynomial form and this is the factor form. Now from the factor form, what are we going to do? Let us see. So the step number over here, step number 2, we have found our characteristic equations. Okay, now to find the minimal equation, all possible combinations of this factor form you try to write down. So the first combination is lambda minus 2, second one is lambda minus 2 times lambda minus 2, then lambda minus 2 times lambda minus 5, and the entire, all the 3 factors together. Okay, now we go for checking for annihilation. So let us see. Note that choice number 4 is obvious, but we want to know, is there any polynomial whose degree is less than that of the characteristic polynomial? Okay, because characteristic polynomial by default is annihilating because of the Cayley-Hamilton theorem. But is there 1, 2, 3 standing smaller than that for annihilation? So let us see. Now to check for correct choice, that is, check f of a is equals to 0. Now how do you check that? Consider the choice 1. F of lambda is equals to lambda minus 2 is the choice 1. You have to check that lambda is equals to a. When you put, do you get f of a is equals to a minus 2i? And it is obviously not going to be 0. So it's not a 0 matrix. So choice number 1 is not the minimal polynomial. Thus lambda minus 2 is not equal to 0 for us. Okay, so it's not the minimal equation. The next one, go for choice number 2, f of lambda. When you simplify it, you get lambda square minus 4 lambda plus 4, and then further when you substitute lambda equal to a, you solve this matrix and you obtain your answer as this, which is again not a 0 matrix. So again f of lambda is equals to lambda minus 2 the whole square is again not equal to 0. So this is also not the minimal equation. Go for choice number 3. Verify that lambda minus 2 times lambda minus 5 is nothing but lambda square minus 7 lambda plus 10, and then further when you go and you plug up lambda equal to a, you obtain a square minus 7a plus 10i, and then when you check, it becomes 0. So that is your minimal equation, because minimal equation is unique. So f of lambda is equals to lambda minus 2 times lambda minus 5 is the minimal polynomial, and hence we have done with finding minimal polynomial. Okay, so try these 3 examples on your own and let me know what are the minimal polynomials that you find for them. If you have any difficulties, I'll be glad to help you. Thank you.